Robotik in der Industrie. Der Podcast mit Helmut Schmidt und Robert Weber. So, hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Sieber. Good morning, Robert. Long time no see, no hear. Good morning, good afternoon, good evening to all of you, dear listeners.
Great to be back, Peter. So we have a very interesting episode in the main part, but before we start with the main part, let's do a quick news part. What do you have?
I'm going to talk about April 1st, Fool's Day.
Oh, okay.
My latest hypothesis, I think it's going to be the end of April 1st, Fool's Day. In a world full of hype and fake, how could we ever survive with or without April 1st? Not sure. It's already a week or two back now, but did you experience one or two of those incidents, April 1st, Fool's Day, Robert?
Normally my kids are involved in this, but this time they missed it, so it's quite...
They missed it. That's almost already going to support my hypothesis, but then they are kids. I'm going to share one of you. So this is from SAP, Digital Manufacturing. They say, introducing SAP Digital Manufacturing Agentic AI Edition. Now our AI agents will run your factory for you. Fully autonomous production, scheduling, self-repairing machines, robotic workforce management. And it's one of those, AI-generated images, and you skim over and you think, yeah, sure, why not? Everybody can say anything, right? But I didn't see anything weird about it until maybe at the bottom it says coming April 1st. But I hadn't thought of anything weird. What is wrong about robotic workforce management? What is wrong with self-repairing machines? So until somebody was suggesting, and I think there was sorry, I didn't see the name. If you are hearing this yourself, you were saying, oh, okay, I'm going to laugh about this myself. We, SAP, we were making fun of it. And I thought, well, are you really making fun of what other people are doing already? That was a bit strange, I think. So bottom line still is, are we going to, is any day in the near future going to be an April 1st Fool's Day? Because, it's so difficult to skim through and recognize what is truth from reality.
Absolutely. That's interesting, yeah, because I read an article, I think in the German Handelsblatt, that SAP is now working on a new AI strategy. Let's see, what does that mean at the end?
There you go. But it looks like at least one of them is not yet so fully convinced about their strategy. They're making an April Fool's Day out of it. I didn't go into the detail. I only saw, maybe you can confirm that. I don't want to put wrong rumors, but there was a suggestion, there was a headline somewhere that their stock had gone down rather strongly. But again, I want to be very careful with this, because I did not check. Every now, what I've been doing, to be very honest, is to check the NVIDIA stock for a year every now and then, just because I know where it came from. That's even not specifically for personal reasons. It's for whatever. But it's almost, for me, that's like there is a number in my head, and if I know, and somebody is saying the market is going down or up or whatever, I just look at the NVIDIA and then I know, okay, if it's still around the number that I have in my brain, then everything is fine. If it's really below or above, and the last time it was strongly above it again, and that's a number I've been following almost like for a year. So were you reading the article? Was that correct, that their stock has been...
Yeah, I think the most valuable company in the German stock market is now Siemens, I think.
I saw that, yeah.
SAP was the lead the last years, but they lost traction, I think. And for sure, when you see what's happening with Anthropic, we discussed this last time. They want to go into the tabular thing, right? Tabular data. That's a SAP domain, right? So they need to act, I think. Yeah. Oh, Sepp is next to me. Yeah. Sepp is a greeting to the podcast.
Okay, Sepp.
Hello, it's me, Sepp. Vorreiter. Yeah. Cool podcast you're doing.
Thanks, Zep. So let's go on, Peter. Yeah.
I was just writing down Zep's name. I was going to check with you anyway, more off the podcast, but I was looking at the people coming to our AI in the Alps, and I wrote down Zep as number one. I always do that, as you know. When there's new names people that I maybe do not know, I put a picture next to them. And Zep is number one without a picture exactly. Because I know Zep from the very beginning. So great to see and hear that Zep is with you, close to you, and coming to us to the Alps.
Yeah, I would like to briefly look back at our episode on leaderboards last week, because I was surprised. I received a lot of feedback and a great deal of support for the researchers from Paderborn. And I received an email, and this is very interesting. It's written, "Hello, Robert. I wasn't aware of this topic before, and it's great that you also shed light on what might seem like niche topics." Because leaderboards are really niche topics, but I think it's a good way to describe our podcast, right? We also shed light on niche topics, not only agentic, but also niche topic when it comes to research, when it comes to industrial AI. And I'm really happy about this feedback, because it's all about what we are doing every week. Thanks a lot. Yeah.
Very good. So that is specifically is it the time series leaderboard? Or?
Yeah, the TS Arena,
yeah.
Exactly.
Because, and I do still look, and what is the name of that other leaderboard? You know, I've been following Peter.
It's FEF-Bench and Gift Eval. Yeah.
Yeah, right.
And LLM Arena.
Yeah, that's the one where in the beginning, yeah. And I think there is a Peter. What's Peter? Peter Sotak? Well, no, what is his name?
Yeah.
And Peter has been there, and I think he joined him now, yeah. So that's where I don't really actively involve. I thought it was a great idea from the beginning what they did, and including now the time series leaderboard as well. They are very important.
Yeah, but it's a niche topic. It's not like, let's talk about the new agentic workflow by I don't know who. But it's good that we also shed light on niche topics for our industry guys. Yeah.
Most certainly. And I think I did suggest in the past that I'm being thrown back like, whatever, is that 30 years now? Maybe not as much, but maybe it is. And now there was the time of looking what processors do. There was a time I started with, 46 was just in the market. People who have heard about 46, that was just before Pentium, right? When I see the three numbers, 4, 8, and 6, my brain brings me back immediately to that time, right? And that was the time when everybody, I think it was like a Ziff Davis magazine, and everybody was talking about leaderboards on how to compare processors. And that time, it was a time of Motorola. Motorola was the very big number one in graphics. There was no, am I correct in saying there was no NVIDIA? I want to be careful. But at least not under the name of NVIDIA, that was not. They were maybe somewhere on a very specific graphics leaderboard. But I mean it more in general. So how do you compare x86 and the new processors that were coming, all the Pentium? That was very, very similar to what today is happening with our LLMs, I guess, right?
But this was important for your industry, right? So you were a part of this industry, and you were looking at the leaderboards. But for the consumers or the customers, was not important, the leaderboards, right?
In the end, not. Well, I mean, that's how I must say we at Intel at that time, we did this Intel Inside. That was at that time for the consumer. We were telling the consumer, it doesn't matter whatever PC you're going to buy as long as there's an Intel inside. That's and of course a big branding thing. And I think at this time we are at exactly the same phase where the decision makers of industrial AI who cannot wait another year, or they don't want to, they already started and want to continue doing things. They need to be able to have a good feeling for what are the different solutions giving me. And then at some point in time, they're going to make their decision. One is going to say, I want to have the best that has been the best, and if the next week there's going to be another one the best, I'm going to take that one. Somebody else has different reasons for choosing the one that is maybe number 2 or number 3, but still very good, or whatever. And in that perspective, it is the same as the IT decision makers maybe 25 years ago and still today. But today in more in a market that's very mature, there's other reasons. There's other reasons why you're fixed already in a certain architecture maybe. And I think with the market in which we're in, with AI, with LLMs, with all the things taking place, it's very, very useful that you can go and look and see who's doing what.
Exactly. So what else do you have, Peter?
For me, the next topic is about getting deeper into the meaning of industrial grade AI, edge AI. There's Stephen Yates. He started a discussion. He says PLC's got one thing right, that the edge AI industry is unlearning, which is about keeping authority local. Now, you know that edge AI has been one of my, kind things for a very long time.
I think we started with edge AI.
Yeah, I think so. Actually, yes. Meanwhile, still at Softing, and we were doing the industrial AI. We started with edge at that time. Now, somewhere in the discussion, there's a guy called Kiran Zebach. He summarizes the discussion nicely. He says, AI can be probabilistic, but the local trust and the enforcement boundary cannot. That was beautiful said when I read it. And before, in my words, and I want to share those, I said, assuming AI adds value, right? Because if not, there's no need for going to deploy it, right? Its execution still cannot be less than industrial grade. I use the term industrial grade that we always say Boris from Siemens has come up with, right? E.g. by means of a deterministic governance architecture. I want to step back a little bit. It's very interesting, I believe, to understand where Stephen is coming from. Stephen, he started his career as a hardware engineer. And it's almost like getting back to what we were just talking about, designing PLC CPUs at GE, Fanuc. There was another discussion that just comes to my brain right now. It's always about IT/OT. This is a little bit separate. I come back, but it's exactly the same topic. And then I was looking back, because I said IT and OT have been separate since they were developed. And then that was very, very interesting. The first PLC was actually before we had a PC. It was I'm not sure which one it is. I think it was the Modbus. I'm not sure which one it was, but it was 1968. We had already, and they were not like on a microprocessor, but they were on different subsets. But it's very interesting to know that at the time that like Intel was doing I just said 46, and then it was a 4004 processor. Other people in a different part of this world were designing their PLC CPUs in this case. So Stephen was one of those guys. And he says the PLC sat and still sits in the cabinet next to the motor, the valve, the conveyor. And it's running its ladder logic locally, whether the network is up or not. And that is the big point, right? Even if later on there was a network and it was down, the PLC knew exactly what was happening, right? So the authority never left the cabinet. And now he says, if we're going to go with edge AI, then we're going to assume that the connectivity between what is happening on the side of what has been the PLC and all of my elements in the network is going to sit somewhere else, right? And he says his point is the edge needs to become its own governance domain, which in the past the PLC has always been. Now, maybe sounds a little bit complex maybe, but I think it's a very, very important topic. The idea being that if today something happens in your production environment, right, then the PLC knows about it, knows that something is wrong and makes a decision. If with edge AI, something happens at the edge and your network is not connected to a central government, then maybe the edge is still going to continue to work. I think that's the basic idea. And the central government organization is not aware of it. Is not aware that something is happening. So I think it's a very important topic. So I asked Stephen, who is the CEO of Federant, to come and share his vision in a podcast session about what he calls connected autonomy for edge AI.
Very interesting concept.
Very important as well, yeah.
Where did you find it? On LinkedIn?
Yeah.
Okay.
Typically, those things do happen on LinkedIn. Yeah.
Very interesting.
For me, that's the main place where I get the information. Yeah, I'm not sure. I mean, you're going more to
conferences.
You went to the robotics conference, I believe.
Yeah, exactly.
I do that less. Hanover, we've been in the past. So I'm not going to be there this year, but I did see, for whatever reason, I see a lot of what should I say, messages with regards to coming to Hanover. Please join me. But so I was just saying, yeah, LinkedIn is the major source for what I see happening in the industrial AI space. Yeah,
it's very interesting, the concept. I'm really looking forward to the episode with him because he should explain what does it really mean. Yeah.
Yeah, exactly. And as I said, it's a guy coming from designing, but at the same time, you can expect questions from me to him and say, what about the ladder logic was then, invented at the same time as together with the first PLC, right? And that's where everybody now is saying, and I'm very completely open to that. And that's what I'm going to be asking him. What about new young people interested, studying, learning, but at the same time, the older generation like himself who now sees the capabilities of AI and saying, do we need to stick to the ladder logic? And of course, that's a huge discussion with, 99% of the people or 100% of the people having learned to deal with the ladder logic. And then now people saying, well, I don't need the ladder logic anymore. But at least I'm saying we need to be in the end where the rubber hits the road. I believe that is kind of the discussion of what we call industrial grade. We need to be deterministic. We cannot be probabilistic. We're going to say, okay, one time it works and the other time it is not. We need to be able to. So I think the potential of AI is to do all kinds of things very specifically, maybe around the generative. So the Jakub Tomczak side of the AI, I would say it can help us to marvelous great things, but I believe it has to take place in the end when we do the execution in a deterministic way within certain boundaries.
What else do you have, Peter?
I have two more.
Oh, two more.
One is an April 1, but it's not an April 1 fool's message. At least I believe not. You tell me. Munich-based Agile Robots, they closed the acquisition of the ThyssenKrupp Automation Engineering. Now, that had already been announced end of 2025. Not sure if we announced it at that time. It wasn't in my brain specifically. Now, what is interesting...
It was robotics.
Yeah, so it's the ThyssenKrupp Automation Engineering, more than 75 years engineering, including robot systems, 650 engineers, 10 global sites. And Agile Robots is a 7-year-old DLR, stands for Deutsche Luft- und Raumfahrt, German Aerospace Center, spin-out, 2,500 employees. Is that correct?
Yeah, the DLR. Yeah.
I couldn't believe that they are so big. Focus on advanced robotics to make AI manufacturing smarter, more flexible. And they having acquired the former Franke Robotics, right? Now, following its acquisition, the renamed, now called Krause Automation, together with Agile Robots, they will shape the next generation of physical AI in industrial production. That's exactly what everybody's doing. I don't mean that in a negative sense, but the physical AI, since Jensen has brought it up. When did he? Half a year ago? Was it last year? I don't know.
Oh, yeah, last year, I think.
Yeah, but it's amazing. But I really mean that. I mean, if you look at where you and I started 7-8 years ago, and now everybody doing industrial AI and then the physical AI in industrial production, right? Now, the second thing related to Agile Robots, I saw it was their strategic partnership with Google DeepMind. And that's kind of what we talked about 2 weeks ago, right? Because in our news section, we put up the hypothesis.
Talked about Google, intrinsic.
Yeah, we put up the hypothesis, and I've seen it again somewhere else. The discussion around it, is Google going to become yet another robotics company? And I said, I don't believe it. I believe they're going to become the Android for robotics platform layer. And at that time, we referred to this intrinsic. They had some kind of activity up on their website. And this seems to be like another announcement supporting. And then there were other people saying, oh yeah, there's so many companies who are trying to put this platform layer there. And then I was asking, somebody else was suggesting, well, who are their potential contenders? AWS. Did somebody suggest Tesla as well? And then I thought like, well, okay, if there's one company who is capable of really doing it, who's done it once with Android, right, for the handheld, what is it, 90% of the worldwide market? My feeling was that they could do it, and I was just going to refer to this as a potential, confirmation in the direction of. Not sure how many partners they have in the meantime that they could be doing this Android for robots layer. I'm not sure what you think of that idea.
Yeah, I think I will talk to Lawrence. I think at the end of April, he was part of our AI in Amsterdam group. He's a R&D guy from Agile. And we will do an episode on that topic. And it's a perfect topic because in the main part, we have the Neura guys also focusing on robotics. So, but we come later to the main part, but very interesting. I will ask Lawrence if we can talk a little bit also about the DeepMind cooperation in the future. Yeah.
Okay. Yeah. Good. Yeah. Looking forward to. Who knows? It doesn't have to mean that just because they did the handheld market they can do, but they have been in this in the robotics market quite some time, and so yeah, it's just my feeling that that's what it is they're gonna be trying to do. The final one that I have here, maybe before you then share what it is that you're talking about in the main section, there's James Buniak. He launched Snap PLC. He says, just take a picture of your control cabinet and our AI automatically generates the entire PLC program. Very impressive. Advanced features, reconstructs ladder logic. There it is again. From the way the wires feel emotionally connected. Listen what the verbiage is, right? It detects undocumented logic written by contractors in 2007. Wow, this feels like magic, right? It predicts which I/O point the electrician meant to land. It gets better all the time. And it recreates the original programmer's thought process, including panic. I'm not going to say more. It's just...
You will record an episode with it?
No, I will not, because this was actually an April 1 Fool's joke. In case you hadn't learned yet. I think it was a wonderful way to represent the frustration, and you can, if you haven't been around engineers that are being called on site, and all they find is exactly this ladder logic. And somebody touched the running system 10 years ago. And now for whatever reason, something has gone wrong. You do not know what is wrong. And then the programmer, needs to go into, there's no documentation or nothing. But again, that's the thing I again will talk to Stephen about as well. It's finding out, do we need to go into this ladder? I mean, which elements, maybe just to round it off around the April's 1st, which of these elements are more, now to turn it 180 degrees around? It's almost like these things are too good to be true, but some points of these, I do believe, will become true in 1 or 2 years. Really, and this is meant to just make fun and joke and the frustration of the electrician. But I do believe that AI will help us to, and I haven't been smoking. I do believe that in 1 or 2 years, certain elements of this, yes, exactly, that's what AI is going to be helping us. And I think the central question for this, nevertheless, is like, are we going to then stick to the things that we have been doing? Or are we going to be doing things a different way? Or maybe even, so with AI on top of it, let the AI take care of the ladder logic. I understand that's a very, very, what should I say, dangerous maybe saying, because there's going to be now many of you saying, well, Peter, what are you talking about? You can't do that. But that has been said about, coding years ago, you recall. And now, everybody is kind of doing it one way or the other. So let's see if certain elements of this April's first Fool's Day joke is nevertheless going to become capable in the near future. Robert, what do you...
It's a better joke than the SAP joke. Yeah,
exactly.
So let's move to the main part, because I did an interview with Jonas from Neura, and here's one thing I learned from the interview, because he said everything we do in robotics will require, now very important, new forms of memory and temporal dependency in the future. And this was very interesting. So new forms of memory and temporal dependency. Very interesting episode. I think we didn't talk too much about Neura. We talked a little bit about Neura and their ideas, but we talked about models, world models, new forms of architectures. Very, very interesting episode by Neura and by Jonas. Thanks a lot, Jonas. It was a pleasure.
And if he talks memory, does he mean like physical hardware, or does he talk about the more like the logical structure of memory? Because that's the latter. If it's a latter, it brings me more into, without knowing the details, but like LSTM, XLSTM, I think that's different ways of dealing with memory as well, I believe, right?
Exactly. From my personal perspective, and when I talk to the robotics companies, we will see a revival when it comes to recurrent neural networks. So a new form, a new kind of RNNs maybe, because the memory topic is very, very crucial when it comes to robotics in the future.
Okay. Looking forward to. I mean, you didn't talk about them, but I'm sure you did, asking about his company probably.
Yeah, exactly.
Because Neura kind of refers almost like to our brains, right?
Exactly.
Neurological.
Yep.
I'm not sure if that is correct, but then they gave themselves their names. So it is maybe. That's why he has been talking about the memory and the way that maybe you're always got to be careful, not our human brain works, because the people who know about that always say, well, it's still very, very different from the way that algorithms work. But okay, looking forward to listening.
Peter, it was a pleasure. Thanks a lot.
Robert, talk to you soon again. And dear listeners, I hope you're going to be enjoying the main section, and you already enjoyed our news. Have you with us soon again. Bye-bye.
Bye-bye. My name is Robert Weber, and my guest today is Jonas Messner. Jonas, welcome to the podcast.
Thanks for the invitation. Nice to meet you. So my name is Jonas Messner. I'm head of AI here at Neura Robotics. Yeah, I've been in AI pretty much my whole professional life. I've worked in automotive for 5 years, bringing AI into various products that are today out there on the streets. And then, here at Neura, first took over the gyms and built the gyms, but then in the meantime also took over the role of head of artificial intelligence overall. So essentially my responsibility is everything from data to training models to foundation models to deploy these on our robots.
Okay, that's interesting. You are the right person to talk to. Today, we don't want just to talk about robots, but more about your ecosystem, gym architecture models, foundation models. What are these gyms? Can you explain us what are these gyms?
So essentially, the gyms are addressing the big challenge of physical AI, which is scarcity of data. Essentially, what the internet has been to large language models, like large amounts of text and images, this is not there for robotics or for physical AI, because we're missing the real world interaction and like how we as humans interact in the real world, like the sense of touch or also audio or 3D vision. All of that is not present in the internet. So essentially what the NeuroGym is about, that we collect large amounts of such multimodal physical AI data such that we can even build real world physical AI. So this is what the Neura Gym is all about.
So you use your robots in the gym to produce data, or am I wrong?
Yes, so essentially in our gyms, we have hundreds of robots acting in real world environments. So the gym, oftentimes when we talk about gyms, people think, okay, this is simulation. No, it's actually real world physical infrastructure. So physical buildings teleoperate our robots to collect data in real world tasks. So for example, you could think about logistics task where a robot is sorting packages. Or you could think about an industrial task where a robot is assembling parts. And we're operating these robots in the gym infrastructure to then get the data out and train models on it.
So it is a purely, let's say, data approach, because scaling, we learned that maybe the time of scaling is over when it comes to LLM, right? So are there combination when it comes to simulation and using data, or is it really only a data-driven approach?
So simulation, of course, also plays an essential role. But what we see for interacting in the physical world, like for fine-grained manipulation, is that the real-world data is simply irreplaceable. But we're having a multifold approach to our data strategy. So it's about simulation, it's about the gym data, so the real-world physical data. It's also about a special concept that we have in the context of equipping humans with data suits in partnerships with bigger corporations. But it's like a multifold approach to data collection.
Can you share a little bit about your approach when it comes to collecting data in factories, or with who you are partnering to collect data?
Yeah. So to collect data with partners, there are multiple partners that we're partnering with in a big way. So one of them or two of them that are public is Bosch and Schaeffler. So essentially what we're doing in such partnerships is that on the one hand, these companies are, of course, using the gym. So they're using the gym to collect data on the real robot. But since that data collection part is not the solution to do everything. So there is more efficient ways of data collection. We're actually also equipping workers with what we call data suit. So essentially the workers in factories, they get a sensor on their body or sensors. So cameras, tactile gloves, audio, and all of these things that also our robot has, such that they can collect during their regular 8-hour shift, can collect data that we can use for training. So this is a very efficient approach to essentially get large amounts of data from real world factory environments. And the interesting thing about that is such data doesn't exist anywhere on the internet. Of course, such companies are very careful about who they give that data to. And we're in the lucky position to have these strong partnerships with such companies. And they essentially give us access to their factories and give us access to that data, which is a tremendous data source.
Absolutely. But what do you do afterwards when you receive the data? Do you need the annotation of the data, or what is the process then?
So we're mostly working in this context with self-supervised approaches. So we're trying to reduce the amount of manual labeling to a minimum amount. So having been in larger corporations, I know that labeling cost can be a significant factor in such projects. And we're trying to use, on the one hand, self-supervised approaches, but also ground truth sensory around the humans, but also around the robots in our gyms that essentially is overlooking the entire process. And that ground truth sensory can then be used together with also advanced AI models like large-scale vision language models to auto-annotate the data. So the amount of manual annotation that we do is limited to like really minor quality assurance and, like the really tough cases where you still need human annotation, but it's like small amounts that we manually label.
So you mentioned you opened your gyms also for your partners, or am I wrong?
That's exactly the approach that we're taking. So while currently most other players are really focusing on solving everything all at once, all by themselves, which you can imagine, physical AI is huge, right? There's thousands and thousands of tasks out there that have to be solved to make physical AI real. We're taking a very different approach to most other players here. We're essentially in a way, crowdsourcing all of these data to learn the task. So the gym is really meant not for us to go in there and train everything all by ourselves, but to bring in companies into the gyms. So we're bringing in huge companies from logistics, from industrial, from service, like from all kinds of areas. And they go into the gym, collect the data for their tasks, and then also via the gym infrastructure. So the gym is not just the physical infrastructure, but also huge cloud infrastructure behind to do the whole data pipelines, model training and deployment, to enable these companies to train their tasks. And with that, actually do the whole scaling of physical AI.
How do you convince them to share the data in your gym?
So we see that for a fact, everyone wants to go into the gym. So when we announced that concept, actually we're drowning in requests to enter the gym. So because of these companies being all under lots of pressure as well to make their factories more efficient, and with our gym infrastructure essentially providing them a place where they can train these robots, they are all excited about this concept that they want to actually enter the gym such that they can even train robots. I mean, building something like the gym, just every company by themselves doesn't make sense, right? This is where the whole thing then again does not scale, because if hundreds of companies all by themselves again build such an infrastructure, it's very costly. But if we build that once for everyone, this is where the real scaling happens and where the real efficiency happens, because everyone can use very similar pipelines, very similar training and data pipelines to train their tasks.
You mentioned data pipelines, training pipelines. Yes, we stop when it comes to annotation, right? Can you go further in the process to explain a little bit what happens then?
Yeah. So essentially in the gym, we have two kind of modes. Yeah. So we're facing, of course, lots of companies that essentially have very little knowledge in the area of how such models are built. And what we're trying to do here, or what we do, is that we completely abstract this process of data pipelines and training pipelines away from these companies such that they can fully do the operation by themselves. So they focus on the data collection piece and essentially then just feed that data into our gym infrastructure to train the models. And all the magic happens in the back. That's what we're focusing on. But to give you a little bit of details, it's essentially, I mean, you're getting that data, you're annotating the data, you're also in these pipelines, you have curation steps that you can look into, okay, what's actually the relevant data that we should train on? Then there's the training pipelines in these infrastructure, there's deployment pipelines to get it then either back on the robot itself, or also depending on the use case and the task, do deployment towards our cloud infrastructure being the Neuraverse.
Exactly. That was my question. Is there a connection between the gym and the Neuraverse at the end?
Absolutely. I mean, the Neura Gym and the Neuraverse are like one and the same. It's like yin and yang. One doesn't exist without the other. So essentially, while the Neura Gym is this data factory and the entire training pipelines to train these skills, the Neuraverse is the place where you in the end build your overall applications and you do fleet management and you oversee essentially what your fleet of robots is doing. So they're essentially one and the same. Yeah.
Okay. You mentioned now data. You missed a little bit the whole topic when it comes to models, right? So which role do models play in the gym?
Of course, the models are a core piece. Yeah. So it is always a model that's trained on the data, right? And here we're approaching that topic in a multifold way. So of course, we're using and we're building also on existing models that are out there from big players like NVIDIA or also Google Gemini, like making use of these models and tuning them to our needs. That's one approach. Yeah. But at the same time, we also see that such models that are out there today, mainly being vision language action models, that they're functional in some cases, like in the rather, I would say, easier cases, but that in many more complex real-world interactions, these models face significant limitations. Because think about it. Us as humans, do we rely on vision only to execute in the real world? I mean, no, right? We're really multi-modal humans. Like, we have a great sense of touch, which is usually a very big portion of our interaction in the real world. We have a great sense of hearing, plus also 3D vision. Yeah. And what we are building also by ourselves is own physical AI foundation models to address these shortcomings that also models that are today out there considered state of the art that these have. So we're going even a step further also on the model side to solve many more complex problems than these VLAs, these vision language action models, are able to solve today.
But what is the problem with the VLAs? Is it a memory topic? Is it a sensing topic? What are the main obstacles?
So it's pretty much the sensor modalities. So think about a task where you do not just pick up an object and place it in some other place, but you have to do some more fine-grained manipulation in the real world. For example, you have to stick in a cable into a hole or something like that. There, the force feedback, or what you then feel on your sense of touch, on the tactile sensors on your robot hands, is essential for task success. Without this data source, you may still be successful in some cases, but your success rate in terms of task success is much lower than if you make use of this data. And this is why and there's similar examples for bringing in audio, where actually we have examples with some of our partners that show, we have this welding topic where we see, the best welders in the world, they actually don't weld based on vision, but based on what they hear. Yeah, it's actually fascinating to when we learned that, because that's not what you would think intuitively, but it's actually the case. Yeah,
absolutely. We had an episode on that topic, I think, together with the rocket science guys in Switzerland. I think they are also using sound for welding applications. Yeah, I was also surprised to hear that the best welders on the earth can hear what is wrong.
Yeah, and that's really that's how us as humans interact in the real world. We're multimodal humans, you could say. And that's simply not covered in vision language action models. And the nice thing about vision language action models is you can train them on internet data. And that's also one of the main reasons why you see all of the big tech companies doing that, because they have access to these huge amounts of data, like we as well do, but they don't have access to the actual multimodal data that you need to train such systems as I just explained them. But that's where we bring in the gyms, right? So that's how we are actually able to train such systems.
But what about memory? I think when we talk about robots or the next generation of robots, we need more memory to understand what's happening in the environment, what I did in the last 2 minutes, or when I look back what I did 5 minutes ago, or who I am, how I handled the situation. Isn't memory a topic for you?
Absolutely. I mean, memory is a core piece in our own models as well. And that's actually also one of the shortcomings, in addition to the multimodality of today's vision language action models. They're typically frame-based. They have no sense of temporality. And this is where we are also introducing essentially a sense of memory with the robot knows what did it do 2 seconds ago or 10 seconds ago or a minute ago. So absolutely, that's a core topic as well.
So coming back to the gyms, is it an R&D lab for you, for your customers, building models and then publish the models in the Neuraverse? Is that the way to go?
Yes. So it is you could call it an R&D lab. I would much more call it really a training world where you can train your use case, realize the use case, not just collect data and train, but then also validate that it's actually successful, and then bring it into your into your actual application in your factory, for example, or in your logistics environment. And the way you do that is you train, or you collect the data, you train the models, you validate them in the gym. And once you're happy with the results, you achieve like your 99% success rate, you can publish it via the Neuraverse. And that's, again, another part where it becomes really magic is if we talk about, for example, a logistics partner that we have, they're training right now with us, like package sorting, as I described earlier. This skill of sorting packages is, of course, useful to many, many more companies. Yeah? And they can then publish the skill via the Neuraverse and even monetize the skill via the Neuraverse.
So it's also a platform, right? To sell something.
Exactly.
Okay, that's interesting. You mentioned NVIDIA and Google, right? So they have a lot of great VLAs, but you mentioned that they are trained on internet data, on public available data. Now you have this amount of data. You are collecting this amount of data. You're building now, as you mentioned, own models with memory, with more capabilities. And you have this platform in the future, or now, and you already have it. Is it a second business model, or is it not to sell robot, but also to sell, let's say, VLAs, models, new version, new approach it when it comes to VLAs made by Neura? Is that the way to go?
Yeah. I wouldn't say it's the second, but it's like directly in parallel. So, of course, we're selling our robots, like the full stack hardware, but our platform is, already in parallel being sold. It's a second revenue stream. You're absolutely right about that. And it's usable not just for Neura's own robots, but in the same way also for other robots. And also here again, we do not believe that we solve every robot embodiment for the entire world, but that there can be other robotics providers that bring in their hardware, also bring it into the Neuraverse, train their skills via the Neura Gym, including our own foundation models that I just described, and enable also these robots from third parties. So for us, the platform, it's not dependent on being for Neura robots only.
So it's an open platform, right?
Absolutely, yes.
Okay. And the main topic is then that these models need to generalize, right? In different robotics application. How difficult is that?
The way that this works is that most of the parts of the model are actually the same across embodiments, because it doesn't matter whether you have a wheeled robot or a legged robot or even just a single arm robot, as long as they have a similar camera or as long as they have a similar sensor for the touch or for audio, they will perceive the environment in the same way. The way they interact then, that's of course then slightly different between different embodiments, but the majority of the intelligence, the whole sensing and the thinking and how you want to solve things, that's the same across all embodiments. And in the end, it's rather like you may call it like an embodiment fine-tuning that enables to do the right movement of the robot, but the perception stack is the same. Yeah,
we will see new, let's call them AI integrators that are doing this fine-tuning for the companies at the end as a business model.
So I think the whole thing in the gym infrastructure is there will be companies acting in these gym infrastructure that may be an entire new market for companies to act in, to actually enable companies to train tasks or to collect data for certain tasks, to then train the models and then to bring these models on the robots. Because it doesn't need to be, of course, the logistics company that goes into the gym. They may actually subcontract that to data and training companies or to service companies that do all of that in the back. But still, they would do that in our gym infrastructure.
And the gym infrastructure, does it cost me? What is it? Is there a price tag on this gym infrastructure for me as a customer or as a partner or as a client?
Yeah, so there is, of course, a price tag behind. I cannot talk about the exact numbers now here, but what we do essentially is, especially now in the beginning, if you buy a robot from Neura that comes with a certain amount of, say, training capacity and data collection capacity that you can do in the gym, such that you can actually enable your robot to train and learn the tasks. Yeah.
Okay, Jonas, at the end, what is on your AI agenda? So you mentioned models, new kind of models. What else is on your AI agenda?
So for us right now, it's really about the topic of scaling and scaling this gym infrastructure to enable the entire world. And we're actually having already like our gyms being currently built up in Germany, in China, also in the US and Japan planned. So currently our focus is really on scaling. On the AI side and in terms of technology, we're of course also following like several trends. Currently, many people are talking about world models that may be a completely new approach, but and also there may be entirely new approaches to how to solve AI. The interesting thing here is that our whole efforts in terms of data collection and in terms of building the pipelines in the back, they will transfer one-to-one if then suddenly a new methodology rules physical AI. Like the data source that we're growing in the back, that will transfer one-to-one. And that's also why we're focusing on that scaling so much and not just worrying about, okay, what's the right model to right now succeed? Because, I mean, this whole technology of foundation models is so young, right? It's a few years old. It will certainly change. The types of models that we see today will not be the types of models that will be the ones that solve things in 3 or in 5 years. But what will be the same is the data. And this is why we focus on that data part so much and getting that right and getting good, high quality data and also the right amounts of such data, such that even if the technology advances significantly, we're always having that huge source of data in the back.
Okay, Johannes, I keep my fingers crossed for you, for your company, for your gyms, for your Neuraverse, for your new world models, for your new VL8s. Thanks a lot. It was a pleasure.
Thank you so much.